This video is the problem of the day for 8th grade math. This is our third packet and it's day 3 of our third packet. And in this section of the packet, we're going to be comparing linear functions. We're going to do the first problem together as this problem of the day. This problem says, who will have $1,000 first, Becky or Olga? And in the first box, it tells us that Becky has $100 and is saving $10 every week. In the second box, it says Olga's information is shown in the graph below. And we're given a graph that has time in weeks on the x-axis and how much money she has on the y-axis. One thing that can make comparing linear functions challenging is when they're not displayed in the same format. For example, Becky's information is given to us in a description, a sentence that we have to read and make sense of. Olga's information is given to us in a graph. If they were both given in a graph or both given in a description, they'd be a little bit easier to compare. So one of our strategies here is to create the same representation for both scenarios to make them easier to compare. So I have a description and a graph. So I have two choices here. Choice number one is I could turn them both into descriptions. I could turn them both into graphs. I could also choose a different representation. I could write an equation for each one and compare those. Or I could make a table of values for each one and compare those. And I can pick whatever representation I'm most comfortable with or I think would be easiest to solve this problem. So let's start by practicing with writing equations. So the equation for a linear function always fits the format y equals mx plus b. The b part is our y-intercept, but in a word problem, that b part represents a starting value. Oops, let's see, lost our camera view here. There we go. That b represents a starting value or an initial value or some sort of flat rate, flat fee. And the m is the slope. But in a word problem situation, it makes more sense to think of this as a rate of change. How is the problem scenario changing? So when we read about Becky's situation, it says Becky has $100 and is saving $10 every week. So when I look for a starting value or a flat fee, I can see that is what Becky starts with, $100. And then her rate of change or how her money savings is changing is it's going up by $10 every week. So that information is our M. I'm going to put those into the format. Okay. Now it says Olga's information is shown in the graph below. The starting value or the y-intercept in a graph is right here, where that line crosses the x-axis. If I do a little bit of looking, it looks like we're counting by 50s. So this y-intercept must be 100, or the b value is 100. The rate of change or the slope on the graph, we can figure out by counting rise over run. So what I do is I have this point, I'm going to find a second point, and I'm going to count how much I have to rise and how much I have to run or move left to right to get from that first point to the second one. So it looks like I have to rise 50, 100, 150, 200. So rise 200, and we run 10. So our rise over run, 200 over 10, if we simplify, we get 20. Now, let's put those values into an equation. Now that we have the same format for Becky and Olga, it's a lot easier to compare. And when I compare now, I notice a few things. I notice that Becky starts with $100 and Olga starts with $100. They start with the same amount of information. It's a lot easier to notice that when I have both equations than it was with just the description and the graph. I also notice that Becky saves $10 per week but Olga saves $20 per week. So if Becky and Olga both start with the same amount of money, and Olga saves more every week than Becky, I know that Olga is going to get to $1,000 first. So my answer to this question is Olga.